Hello coders, welcome to my video. So in this video, we'll discuss about a volatile keyword, that is a type specifier in C that tells the compiler that an object value may change at any time by means of, you know, outside the current program execution control. So what do you mean by that? So due to the compiler optimization, sometimes our executable or our compiler think that like okay, if a variable is not modified in the current scope, it cannot be changed. So multiple reads can be merged, unused reads can be removed, and if you are using continuous loop, that variable which we are looking out, that also things like it won't change. So these all assumptions of the compiler optimization can be solved by using a volatile keyword because these function breaks when hardware updates the memory. So we can have some interrupts modifying the variables. For example, we have control C, control Z, and all other interrupts that also can change a variable by pressing some keys. Okay, so we have signal handlers, okay, that run asynchronously, so we don't know when that value got changed. So if the compiler thinks, okay, I will not change this value because this value is coming same due to some certain repetitions, so it's not the case. So where to use volatile and where not to use. Okay. So we cannot put a volatile keyword before every variable. So where to use this volatile mostly is where we have a memory load and store every time. Like there is some loop that is continuously monitor some variable. At that certain condition, this compiler optimization can take effect. So that scenario we can use volatile. Volatile affects the compiler but not the CPU. Okay. So whatever cache is there stored in the compiler that got reflected, not the CPU cache. They have nothing to do with the CPU cache. Volatile is required for memory map IO, as I discussed. For example, we are giving some interrupt on the pin. Okay. So volatile is required for the signal handler as well. So these are the few scenarios in which we can use a volatile keyword. So let's take an example and we'll explain how this volatile works actually. So I have a simple program. Okay. So here I have a variable named stop. Initial value is false. Okay. And I have registered a signal handler, handle SIGINT. Okay. That will take control C from our keyboard, and this signal is being caught by this executable. So we are continuously monitoring or accessing this stop variable. Okay. So initially it is false, so it got true, and every time it will execute the loop. Okay, so I'm just commenting these two lines for now. But once I have this false statement, this while loop will run infinitely and it won't go to this point. Okay, so when I got some interrupt, this section is not interrupted. Okay, so let's compile and see how it works first. Okay, so I'm just closing it and I will be doing GCC uh, volatile variable. Okay, and here I got a dot out for me. So showing program started, press Control C. When I press Control C, it got exited. Okay. So for now, if I enable compiler optimization and I make it volatile 1. Okay. So now if I run volatile 1, and again if I am pressing Control C here, there is no operation. Nothing is happening. Okay. So I come out by pressing Control Z now. Okay, it got stopped. And so this Control C I'm not getting in case I enable this optimization, DCC optimization. Okay. So if I do one thing, if I incorporate some sleep and I'll remove this as well. And now if I try the same thing with the optimization, so this time if I use Control C, see, now I got the interrupt. When I incorporated the sleep, so this is not our scenario. Okay, so we don't want any sleep to be given in this code. So if I remove this, so I got the same result because this variable now run infinitely and no Control C action is there. Okay, so this happen when we enable compiler optimization. If I disable it, so in place of this I disable it. Now there is no compiler optimization. So if I run again and I've used Control C, this time also it received the signal and the stop message is been printed at the end of the program. Okay. So this happened only when I use compiler optimization. Okay. Similarly, okay. So our scenario is I have to enable this compiler optimization and now I have to get the proper result. So what I will do, I will take this example and in spite of using this, I will place a volatile type specifier here. And now I compile it again the same way. And this time, if I run volatile 1 and I use Control C, this time it catches that signal because I declared this variable as volatile. So every time this executable know like I have to fetch this stop variable, forcefully. Not I have to optimize with certain value as false and now keep on going without updating this stop when this interrupt came. Okay. So, so the question is like we have enabled the compiler optimization and we using the volatile keyword here to make this variable to fetch this stop variable every time it got updated from the memory. So what is the difference actually? So if I remove this and now I compile, so what is the difference? And by using the volatile, what is the difference? So we will do one thing. So I will take -e and volatile.I. So I'm just taking the preprocessor state here. And second time, I will take the preprocessor thing and I convert it into compiler friendly code. Okay. When I open this volatile, if you don't know how to compile, just I'll paste my link for the compiler stage where we will see what are the compiler states. And here I get this, and if I go to main, you see here this is a jump statement. So this is our main, and here we have the jump statement that is jumping L6 here only. So we keep on rotating here due to compiler optimization. Okay, and it won't come out from this. Okay, so what happens if I have used volatile here? So same thing I'll do, enable the compiler optimization, and I use this preprocessor state, then compiler state from volatile I to volatile S. And this way, if I open now the volatile dot S, so if I again go to the main, so here if you see, you will get this jump on condition. So every time it's fetching this top variable, okay, and keep on rotating like this in this while loop. So this is, this while loop which works on the condition, and every time it's taking the stop case. But in case without volatile, this thing, they have done the optimization and removed these lines. So this is how our compiler optimization works in the compiler states. So from here you understand where we need to use this volatile keyword and what are the variables we can use this volatile. So we cannot use it this volatile everywhere, only for the specific memory IOs or signal handles which we discuss, that only the place where we will use this volatile keyword. And there are various flavors of volatile. For example, we have volatile, then we have int star ptr. Like this we can define, where this pointer will be pointing to the volatile value. Okay, so that value got changed. And here the pointer address and the value pointed by this pointer, also both of them is volatile, so they will fetch these values again and again. Okay, so this is very simple way to explain what volatile will do. So if you have any query, just mark comment. Thanks for watching my video.